Alright, we have the torch and the lighting port here. It's on. It's kind of making a funny noise. See some smoke coming out of there. Looks like it's frying the sealant or something. Alright, we're running about 5 inches of vacuum. And we have smoke coming out. There's nothing in the filter currently. Just an empty box. Now that we've gotten it lit, I think I'm going to take off the torch. You can hear, maybe you can hear the whistle coming from the intake, from all the intake tubes. Still at 5 inches of vacuum, producing some visible smoke. Now we have thermometer going, thermocouples. I'm not sure which one this is. It's maybe 1 or 2, but we're showing 800 degrees Fahrenheit. So we are rapidly getting some stuff. Let me see if I can get some flame. Just starting to get some flame. Not yet a sustainable fire going. That's still going up. Alright, this is the temperature difference, see the T1 minus T2. That's the temperature difference at the constriction minus the temperature difference at the bottom of the reduction. You can see that that's Celsius. There you go. You can see that it's almost 700 degrees difference from the hottest point in the burn. As the gas travels through the charcoal, the temperature is being reduced, and that's because that energy is going to the reaction that converts water and carbon dioxide into carbon monoxide and hydrogen. So that's the energy that's going into that process, and that's called reduction. You can adjust the valve down and change the character of the flame. See, right now the flame's blowing up out the top. Alright, there's full out the top flame. Turn up the pressure a little bit here. You can see my my reactor vacuum is at 5 inches, but the filter vacuum is at a little more than 5 inches. So I'm going to go shake the grate. Moved a little, not much. Alright, so there is the temperature at the reduction bell, 1688. There's the temperature at the bottom of the reduction at 1228. Difference of 480 degrees Fahrenheit. Something that burns a little more brightly. Carbon monoxide burns almost invisibly. See, it has been 1 minute and a half. Uh-oh, we've lost something. Time to shut it down. I've adjusted the air mixture down a little bit so the flame is coming up above the burner, so you can actually see, you can see the heat ripples coming out of the top of there. The flame is actually burning out the top.